Hello friends, welcome to your own channel Online Physics. Here we will provide you solutions of your problems, and here we will also explain the various concepts of physics. So subscribe this channel to getting more videos on physics. Now the first question of this video is, a massy particle with total energy E is constrained to move on a finite plane under the influence of potential V equal to x square bracket x square plus y square. The average kinetic energy of the particle is, so here is the answer. The given potential is x square bracket x square plus y square. Now here we can open the bracket and the potential will become x4 plus x square y square. Now according to Virial theorem, if we have given potential in the form of k r raised to power n, so for that average kinetic energy is equal to the n upon 2 times of potential energy. So here according to question the power of coordinate is 4. So according to Virial theorem we have average kinetic energy will become 4 upon 2 into average potential energy. So here average potential energy becomes 1 upon 2 times of average kinetic energy. So as we know that total energy is equal to kinetic energy plus potential energy. So here put the value of potential energy in the form of kinetic energy. So you will get average kinetic energy plus 1 upon 2 average kinetic energy. It will become 3 upon 2 average kinetic energy. So here you will get the relation between average kinetic energy and total energy. So here average kinetic energy becomes 2 upon 3 times of total energy. But in the options total energy given in the denominator, but it is wrong. The total energy comes at the numerator. So according to this, option A is our right answer. Now the next question is, a massy particle with unit mass moves under the influence of potential V equal to x cube minus 3x plus 2. The angular frequency of the small oscillation about the minimum of the potential is, so here the given potential is x cube minus 3x plus 2. And here we have to find the angular frequency at minimum of potential. So here the condition for minimum is the double derivative of potential is greater than 0 at that point. So here first we have to find out the extreme points, and which can be determined by putting the first derivative of potential is equal to 0. So here the first derivative is 3x square minus 3. So after putting this equal to 0, we will get the points x equal to plus minus 1. And next the double derivative of v is equal to 6s. So at point x equal to 1, the double derivative of v greater than 0. So this is our minimum point. So at minimum point the double derivative will become 6. So now the formula to calculate the angular frequency is omega equal to under root k upon m. Here k is the double derivative of potential, and for unit mass m equal to 1. So we will get angular frequency is equal to under root 6. So that is our right answer, which is option A. Now the question number 33 is, if A is 3 into 3 matrix with trace equal to 3, determinant A equal to 0, and one of the eigenvalue 1 and the other two eigenvalues are, now here we have to find the other two eigenvalues. So here the trace of matrix A is equal to 3 and determinant of matrix A is equal to 0, and one of the eigenvalues is equal to 1. Now here we have trace of matrix is equal to sum of eigenvalues and determinant of matrix is equal to product of eigenvalues. So here let's say lambda 1, lambda 2 and lambda 3 are the eigenvalues, and now according to given condition the trace is the sum of eigenvalues, which will become lambda 1 plus lambda 2 plus lambda 3 equal to 3, and the product of eigenvalues is equal to determinant. So here lambda 1 dot lambda 2 dot lambda 3 is equal to 0. Now from the given options lambda 2 equal to 2 and lambda 3 equal to 0 satisfy this condition. So option A is our right answer. Now the question number 34 is, the following vector is orthogonal to the vector A I cap plus B j cap. Now here from these options you have to find out the correct option which is orthogonal to the given vector. So here for orthogonal the angle will be equal to 90 degree. So the condition is, if A and B are two vectors, A vector dot B vector is equal to magnitude of A and B with cos theta. So if theta equal to 90 degree, it will equal to 0. So here if dot product of two vectors is equal to 0, then these vectors are orthogonal. So now in this question for option C, the dot product of these vectors will equal to 0. So that's mean option C is our right answer. Now the question number 35 is, if r vector is a position vector, the value of del square r dot r equal to del square r square is equal to, so here r is the position vector which is equal to x I cap plus y j cap plus z k cap. Now here r dot r will equal to x square plus y square plus z square. So del square r square will equal to 2 plus 2 plus 2, which is equal to 6. So here option A is our right answer. Now the question number 36 is, an AC voltage source with 120 volt and 60 Hz is connected across a 2 microfarad capacitor. The power loss in the capacitor is, now here the formula for power is V dot I cos theta. So here we have voltage source connected across the capacitor. That means here theta will equal to 90 degree. So as we know that cos 90 is equal to 0. So that's mean the power loss is equal to 0. So here option A is our right answer. Now the next question is, a particle is described by the Lagrangian L equal to m upon 2 exponential minus alpha t x dot square plus y dot square minus half kx square, where alpha and k are constants. One of the following statement is correct. So here the options are Px is conserved, total energy is conserved, Py is conserved and Lz is conserved. So here we have to find that which quantity is conserved. Now here the given Lagrangian is m upon 2 exponential minus alpha t x dot square plus y dot square minus 1 upon 2 kx square. So here first let me check about conservation of linear momentum. If some coordinates which represents a distance is cyclic, then corresponding generalized momentum is conserved. So in above Lagrangian, y dot is cyclic, so that's why y component of linear momentum is conserved. So here the right option is option C, which is Py. Now let's discuss when total energy is conserved. The total energy is conserved if Lagrangian does not explicitly depend on time and potential does not depend on velocity. Now here you can see that the Lagrangian is dependent on time. So that's mean the total energy is not conserved in this case. And the option D is z component of angular momentum. But here the given Lagrangian doesn't depend upon z component. So that's mean Lz is also not conserved in this case. Now the question number 38 is, if Q1 and Q2 are generalized coordinates and P1 and P2 are corresponding generalized momenta, the Poisson bracket Q1 square plus Q2 square comma 2P1 plus P2 is equal to, so here we have to find out the Poisson bracket for this expression. Now here we have given the two components of generalized coordinate and two components of generalized momenta. So we have to find out the Poisson bracket for the both cases. Now here you can see that how to open this bracket. First take the derivative of first term with respect to Q1 and the second term with respect to P1 minus derivative of first term with respect to P1 dot derivative of second term with respect to Q1. So similarly take the derivative of these terms with respect to Q2 and P2. So after taking the derivative we will get 2Q dot 2 minus 0 dot 0 plus 2Q2 dot 1 minus 0 dot 0. And it will become 4Q1 plus 2Q2. Now here take 2 commons and it will become 2 bracket 2Q1 plus Q2. So that is option D. So here option D is our right answer. Now let's come to the question number 39, which is, one of the following operator is Hermitian. So here from these given options you have to find out that which operator is Hermitian. So the operator is Hermitian if it satisfies the condition. The first is expectation of phi comma a cap psi equal to a cap phi comma psi. Or you can say that integral of phi a cap psi d tau equal to a phi psi d tau. So here when we apply this condition to option D, it will satisfy. Now here you can see that option D is double derivative. So here when we put this double integral in equation 1, you will get integral minus infinite to infinite psi star m double derivative psi n dx. Now integrate this by parts and remember that psi m and psi n are 0 at the endpoints. Now after solving this integral, you will get integral minus infinite to infinite double derivative of psi m star psi n dx. So that's mean it satisfies the condition 1. So that's why the option D is our right answer. Now the next is one of the following is not an eigenstate of the parity operator. Now here we have to find out that from these four options which is not an eigenstate of the parity operator. So as we know that parity is the inversion of spatial coordinates. That means xyz into minus x minus y and minus z. Or you can also say r into minus r. Now when we apply the parity operator on any function, there are two possibilities. The first one is it has even parity and the second is odd parity. If the function remains same, that is even parity. If the function changes into negative, that means it is odd parity. Now let's check which option is not an eigenstate of the parity operator. So here the first one is cos x plus x sin x. So when we apply parity operator on this function, x will change into minus x. So now here we can write cos minus x equal to cos x and sin minus x is equal to minus sin x. So here minus minus will become plus and you will get cos x plus x sin x. That means it has even parity. Now the second option is x bracket cos x plus sin x. So here after applying the parity operator, it will become minus x cos minus x plus sin minus x. So further we will get minus x bracket cos x minus sin x. Now here you can see that this function has neither even parity nor odd parity. So that means this is not an eigenstate of parity operator. So here option B is our right answer. Now the next question is degeneracy of the first excited state of an isolated hydrogen atom is. So here degeneracy of hydrogen atom is equal to n square. So for the first excited state n is equal to 2. So degeneracy will equal to 4. So here option B is our right answer. Now the next question is the normalized ground state of a particle of mass m which is constrained to move inside a potential Va equal to 0 if x existed between minus L to plus L and infinite elsewhere is given by. Now you can estimate from the options that the question is incomplete. According to question, they are asking for the eigenfunctions. Now here you can see that the energy eigenfunctions are given by psi nx equal to 1 upon under root L cos nx upon 2L if n equal to odd and 1 upon under root L sin nx upon 2L if n equal to even. So according to options we have n equal to 1. So that's mean the eigenfunction will equal to 1 upon under root L cos pi x upon 2L. So here option D is our right answer. Now the next question is the weak interaction violates the, and the options are time reversal symmetry, charge conjugation symmetry, space translation symmetry and parity symmetry. Here parity symmetry violates the weak interactions. So that's mean option D is our right answer. Now the next question is the wave function of a particle psi equal to 1 upon under 2 psi naught plus iota psi 1 is given in terms of the eigenstates psi naught and psi 1 corresponding to the ground state energy and the first excited state energy E naught and E1 respectively. The expectation value of the Hamiltonian in the state psi is given by. Now here the wave function is 1 upon under 2 psi naught plus iota psi 1. In the question you have given a bracket in the wave function but there is no any bracket. Now let's see how to calculate the expectation value of the Hamiltonian. So here the expectation value of Hamiltonian is equal to summation of probability of that state at particular energy. Now here you can see that how to solve it. So after simplification you will get E0 plus 2E1 upon 3. So option D is our right answer. So now the next question is the Gauss transformation between the scalar vector potential phi comma a and phi dash a dash is. Now in the Gauss transformation we have same electric and magnetic field even after changing the potentials. So here for option D, which is phi dash equal to phi plus alpha x, a dash equal to a minus alpha t I cap, we will get same electric and magnetic field. So that's why option D is our right answer. Now the next question is the electric field E corresponding to the potential phi RT equal to 0 and ART equal to minus 1 upon 4 pi epsilon naught QT upon R square R cap is given by. Now here we have to calculate the electric field for the given potentials. So here formula to calculate the electric field is minus del phi minus curly A upon curly T. Phi equal to 0, so that's why del phi equal to 0. So now curly A upon curly T becomes 1 upon 4 pi epsilon naught Q upon R square R cap. So that is the electric field. So here the option C is our right answer. So now the next question is the quark content of a neutron is. Now here the answer is up down down, that is option B. Now the last question of this video is the weakest of the 4 fundamental interactions of nature is. Now here gravitation is the weakest of the 4 fundamental interactions of nature and the strongest interaction is strong interaction. So thanks for watching, subscribe for learning and share for helping. Share this video to all your friends so they will also get the benefit from this. And last thing, please don't forget to like this video. Thank you.